In the previous video, we looked at grouping the data using agglomerative clustering. In this video, we're going to take a look at how to evaluate the performance of clustering algorithms. We will first load the input data and then iterate through a range of values of input data to find peak. So far, we built different clustering algorithms but didn't measure their performances. In supervised learning, we just compare the predicted values with the original labels to compute their accuracy. In unsupervised learning, we don't have any labels. Therefore, we need a way to measure the performance of our algorithms. A good way to measure a clustering algorithm is by seeing how well the clusters are separated. Are the clusters well separated? Are the data points in a cluster tight enough? We need a metric that can quantify this behavior. We will use a metric called Silhouette Coefficient Score. This score is defined for each data point. This coefficient is defined as score equals x minus y divided by max x, y. Here x is the average distance between the current data point and all other data points in the same cluster. Y is the average distance between the current data point and all the data points in the nearest cluster. So let's see how to go with it in Python. The full code for this video is given in the performance.py file that's already provided to you. Let's look at how it's built. Create a new Python file and import these packages along with the utility package. Let's load the input data from the data.perf.txt file already provided to us. So we do it with this code. In order to determine the optimal number of clusters, we iterate through a range of values to see where it peaks. So insert this code in your file. Next, plot the graph to see where it peaked. So these lines of code we have used to plot our graph. Now we go ahead to run this code and see the output. So when we run it, we can see the number of clusters. Also, we get the bar graph for these clusters. As per these scores, the best configuration is 5 clusters. Let's see what the data actually looks like. So we go back to the editor and plot the figure. Now we again run the code. So you can see the input data. We can visually confirm that the data in fact has 5 clusters. We just took the example of a small dataset that contains 5 distinct clusters. This method becomes very useful when you are dealing with a huge dataset that contains high-dimensional data that cannot be visualized easily. In this video, we have evaluated the performance of clustering algorithms by plotting the peak graph of data points. In the next video, we'll see how to automatically estimate the number of clusters using dbScan.